Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit number 9, Lesson number 8 on cubed roots. Before we begin, let me remind you that you can find a worksheet and a homework assignment that go with this video by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes at the top of every worksheet. If you take your smartphone or your tablet and scan that code, it will bring you immediately to the worksheet to the video that goes along with that worksheet. All right, let's begin. So, throughout this entire unit, we've talked a lot about square roots. But there's more than just square roots. There's cubed roots. There's roots that are the fourth roots, quartic roots. There are quintic roots. There are roots that go up and up and up. And they're the same idea as square roots. All we're going to look at in this course besides square roots are cubed roots. And they're pretty simple, right? So if x cubed is equal to a, then x is the cubed root of a. Or, better yet, if we're looking at the cubed root of any number, then we're looking for the number that when cubed gives us that. Ooh, right? Very similar to square roots. Notice, by the way that we represent a cubed root is by putting a little 3 in that little nook, okay? Watch out, because commonly, and the calculator just makes this even more confusing, commonly people will write it kind of like this, okay? But that would actually mean 3 times the square root of x. If you want to talk about a cubed root, then that little 3 has to go in the root nook, if you will. Sorry, I don't have a better name for it than that, but it is definitely like mathematical convention, and it's something that you'll get used to just a little bit in this particular assignment. All right? So I'm going to clear out that little bit of text, and let's get right into cubed roots. All right, so exercise 1, it's good to know some basic cubed roots of smaller numbers, and I'm talking about some basic ones. Unlike square roots, which you tend to memorize all the way out to probably like 144, right? The square root of 144 is 12. Cubed roots, we try to limit ourselves quite a bit, okay? So what we're going to do is we're going to find each of the following and justify them by using a multiplication statement. So let's do the first two together. The cubed root of 8. Well, the cubed root of 8 is 2. Why is that? Because 2 times 2 times 2 is equal to 8, right? 2 times 2 is 4, times 2 is 8. In other words, right, or for example, 2 cubed is 8. All right? But that's all a cubed root is. The cubed root of 1, that one's really easy. That's just 1, right? And the reason why is because 1 times 1 times 1 is equal to 1. Or, better yet, 1 cubed is equal to 1. Now, I know that that's a little bit tricky, so think about the rest of them on your own. Okay, if you need to, use your calculator, but try your best to do the arithmetic either in your head or write it out. Keep in mind that you're always looking for something cubed that gives you the radicand, the number under the radical. Still the radicand, okay? Pause the video now and play around with this a little bit. All right, well, the cubed root of 27 is 3, and that's because 3 times 3 is 9, times 3 is 27. Or, even better, 3 cubed is 27. All right. The cubed root of 0, that one's easy. That's 0. It's kind of like the cubed root of 1, right? That's because 0 times 0 is 0, times 0 is 0. Or 0 cubed is 0. All right. Now the last two, those may have thrown you off a little bit, right? Remember with square roots, and we'll talk about this a little bit more in a second, with square roots, you couldn't take the square root of a negative number. But cubed roots, they're not so limited. The cubed root of negative 1 is negative 1. And the reason why is that negative 1 times negative 1 is positive 1. But then when we multiply by negative 1 again, we get negative 1. In other words, negative 1 cubed, notice those parentheses, is negative 1. Same deal for the cubed root of negative 8. That's negative 2. And the reason is because negative 2 times negative 2 is positive 4. And then when we multiply by negative 2 again, we get negative 8. So negative 2 cubed is negative 8. That's it, right? So cubed roots are very, very similar to square roots, but with one really fundamental difference, which is you're trying to find the number you need to cube to get that radicand. All right? So I'm going to clear out this text. You go ahead and pause the video and write down anything you need to. All right, here it goes. Now, actually, before we even move on to the next problem, okay, I want to point out that, like, again, with square roots, a lot of teachers will expect you to know the perfect squares all the way up to 144. But the perfect cubes, those are actually much harder. And let me just show you why, right? 0 cubed, 0 times 0 times 0 is 0. 1 cubed, well, that one's pretty easy. 1 times 1 times 1 is 1. 2 cubed, not too bad. 2 times 2 is 4, times 2 is 8. 3 cubed, well, that's like 3 times 3, which is 9, times 3 is 27. 4 cubed, well, that's 4 times 4, which is 16, times 4 is 64. I'm already starting to have a problem, right? And I'm not very far. 5 cubed is 5 times 5, which is 25, times 5. Got to really start to think about that pretty hard, is 125. And 6 cubed, I'm going to be honest right now, I don't know it off the top of my head. Could I figure it out? Sure I could. 6 times 6 is 36, and then I could play around with multiplying 36 by 6, but I don't know it off the top of my head, right? So perfect cubes, notice how quickly these things are growing, right? They're getting much larger, much faster than squaring. So perfect cubes, right? These are all perfect cubes, right? As a contrast to perfect squares. These are all perfect cubes. And we're not going to do nearly as much with cube roots as we do with square roots. In fact, this will be the only lesson on them. But they are part of Common Core Algebra 1, so you want to get some exposure to them before you get way more work with them in Algebra 2. Anyway, I'm going to clear this out. Let's move on to the next sheet. All right. Now, exercise 2. Using your calculator, use a guess and check scheme to find the following cubed roots. Justify using a multiplication statement. So literally, I want you to take your calculator out right now, and I want you to start playing around with numbers. What's the cubed root of 343? And by the way, these are all perfect cubes. All 3 of these are perfect cubes. So you'll come out with answers that are integers. But I want you to play around with it. See what you can do, okay? But use your calculator, all right? Pause the video now. All right, let's go through them. Well, the cubed root of 343 is 7. Now, I don't know that one off the top of my head, but if I take my calculator out and I put in 7 times 7 times 7, I find that it's 343. Or better yet, if I use my caret button, right, if I put in 7, then hit the caret and 3, I also get 343, which is awesome, okay? Now, this one looks a little bit worse because it's got a negative in there. But again, it's not too bad. You should be guessing negative numbers, though, and what you'll eventually find is that the cubed root of negative 2,744 is negative 14. Again, not something I know off the top of my head, and that's because negative 14 times negative 14 times negative 14 is negative 2,744. Or negative 14, always get parentheses around it when it's negative, to the third is that guy. All right, the last one, man, it seems like it should be huge. The cubed root of 12,167, but that's in fact 23. And again, just playing around, 23 times 23 times 23 gives you that 12,167. All right, so we can determine the cubed root of perfect cubes by kind of a guess and check scheme. And again, I think that's helpful just to get a physical feeling for what a cubed root is, because you haven't had exposure to these in the past unless you had a teacher that did some enrichment above square roots in the past. All right, I'm going to clear it out, so pause the video now and write down anything you need to. Okay, here it goes. Now, maybe you bought your calculator, maybe your school loaned you one. These are some good calculators. There's got to be a way to do it on a calculator. So, exercise 3, find each of the following cubed roots to the nearest tenth by using your calculator's cubed root option /button. Okay, so none of these three numbers, just making sure, none of these three numbers are actually perfect cubes, the 100, the -364, and the 982. So it would be tough to do these by guess and check. We could do it, but we'd have to keep guessing and checking and guessing and checking. So I'm going to show you where the cubed root button is on the TI-84 Plus. If you're using a different calculator, I'm sorry, I'm not, because I'm sorry about it not being a TI-84 Plus, but just that I won't be able to show you where that is. But your user's manual will certainly have it if you look it up in the appendix. So let's do it again. Let's open up that TI-84 Plus. All right, there we are. And what we're going to do is we're going to ask it what the cubed root of 100 is. Okay, so let me show you where the cubed root is. The first thing that we have to do is find what's called the math button. And we've seen this before. We used it before in order to graph an absolute value function. So it's right there. There's my math button. And when I hit it, I'm actually immediately on the right screen. All of the things right in this left-hand corner really have things to do with square roots and powers. Well, roots and powers, sorry. So if you go down a little bit, you see this option. Now it's a little weird because to me that looks like 3 times the square root, but it's actually the cubed root. So I'm going to grab that, I'm going to hit enter on it, okay, and now I just type in 100, and I hit enter. It's as simple as that. And it's ugly again because 100, although it's a perfect square, is not a perfect cube. Right, so that's like 4.64158, and to the nearest tenth, that's 4.6. All right, why don't you make sure you have it? Pause the video now and find the cubed roots in letter B and letter C, round to the nearest tenth. All right, let's go through it. Well, again, here we go. We've got the TI-84 Plus open, might as well use it. Let's do it again. Let's go back into math. Let's go down to that cubed root option. Let's put in -364. Hit enter. And no great surprise, it turns out to be negative. The cubed root of a negative number will be negative, -7.14003, etc. So -7.1. Right? Let's do one more. Let's go back into the math menu. Go down to the cubed root option again. Hit enter. Type in 982. Hit enter. And what do we have? 9.93963, etc. So 9.9. It's kind of cool when you look at letter A to think, okay, here we've got a number. If I asked you what the square root of 100 is, it'd be like that. I don't want to snap my fingers, otherwise the TI-84 would disappear and I'm not quite ready. But it would be easy. The square root of 100 is 10. But the cubed root of 100, that's a messy number. There are some numbers that are both perfect squares and perfect cubes, and I challenge you right now to figure out the smallest one. All right? Well, the smallest one that isn't 0 or 1. Those are both perfect squares and perfect cubes. But what's the smallest number, smallest integer after that is both a perfect square and a perfect cube? Anyway, whatever. Why don't we get rid of the TI-84 Plus and the text all at the same time? We can make that magic happen. Pause the video now, copy down anything you need to. And let's get rid of it all. Ready? 1, 2, 3, gone. Thank you, TI-84 Plus. All right, let's move on to the back side of the sheet. So, one thing you're also expected to be able to do is graph the cubed root function. To me, that seems a little bit extreme, given the fact that you've just learned about cubed roots now. But, you know, it is what it is, so to speak. So let's learn how to graph a cubed root function. Kind of like a square root function, what we want to do is we want to fill in nice values. Okay, so let's do that. Now we could certainly put this into the TI-84 Plus, and we could generate every value we needed from a table. But for the basic cubed root graph, let's do it by hand. Now what I've done is I've listed out here sort of the 5 nicest, smallest perfect cubes. So for instance, the cubed root of -8 is -2, right? That's going to correspond to the point -8, -2. The cubed root of -1 is -1, corresponding to the point -1, -1. The cubed root of 0 is 0, corresponding to the point 0, 0. The cubed root of 1 is 1, giving me the point 1, 1. And the cubed root of 8 is 2, giving me the point 8, 2. So let's see how this looks. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. I'd go to the next ones out, but those are -27 and 27, and that just would be ridiculous. All right, -1, -1, 0, 0, 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. All right. All right. We need arrows on both ends. Unlike the square root graph, the cubed root graph goes on forever in both directions, and that's because we can take the cubed root of negative numbers, whereas we can't take the square root of negative numbers. All right, let's do a real quick verification of this graph on our calculators. That means we got to open up that TI-84 Plus. All right, it's back. Let's do it. Now we're just going to be looking at the general shape here. So let's go into y equals. Okay. Clear out any equations that you might have in y1, y2, etc. Take a moment. All right. In y1 now we want to enter in the cubed root of x. To do that we have to go back to the math menu, go down to that cubed root option, grab it. Now of course you can't forget to type in the x. There it is. All right. Now we want to set our window. Okay, I feel like I've got the equation right. It's pretty simple, but I want to set my window. And if I want it to look like this one, then maybe what I'd like to do is set x min and x max and y min and y max to be sort of the graph paper that I have. So in this particular case, x min is equal to -10, x max is equal to +10, y min is equal to 1, 2, 3, 4, 5, 6 is equal to -6, and y max is equal to +6. So those are what I'm going to actually use as my window setting just to try to get a graph that looks as similar to the one that's on the sheet as what I have. Okay, so let's do that. Let's go into the window, and for x minimum, let's put in -10. Let's go down. For x maximum, let's put in +10. We're moving through this a little bit quicker now because you've done so much graphing this year. Let's go down a little bit to y minimum, and let's put in -6. And then in y maximum, let's put in +6. Okay. Check over that window, make sure that it looks good. And then let's hit the graph button. All right. So, yeah, it looks the way that we thought it would look. In other words, the way that we had graphed it. Maybe our graph isn't particularly perfect, especially right around the origin. I wish I had done a little bit of a better job. But it's a good graph. And what we're going to now do is we're going to move on and we're going to graph one more cubed root function to see if those patterns that we've seen before with the shifting consistently hold true. All right, so let's pause the video one last time and copy down anything that you need to copy down. All right, and now what I'm going to do is clear out the text. All right, let's do one final cubed root graph. So here we've got the function the cubed root of x plus 2 minus 4. The cubed root of x plus 2 minus 4. So what we're going to do, since we've still got that TI-84 plus open, we're going to put that now back into y equals. Okay, so let's hit our y equals. We can go right back in there, right from the graph. Okay, now we could clear out that function, or we could go under the cubed root and we could just put in x plus 2. So let's do that, right? Where there's an x, let's go back in there and let's put in an x plus 2. Okay, if you're using an older calculator, you'll have to have parentheses there, all right, like the TI-83 plus. But let's put in x plus 2 under the cubed root. Then I'm going to have to use the right button to get out of the cubed root and put in a minus 4. Okay? So now I've got a good-looking graph, again, or a good-looking equation. Again, if you're using the TI-83 plus or something with an older OS, it'll probably look like this. All right, whereas mine looks a little bit more like what the function actually has. Now, we're going to go in and we're going to create a table of values this time, like we did with a lot of the square root functions. And I want to show that table. Now, as we already saw, our x minimum on this graph paper was negative 10, and our x max was a positive 10. So I'm going to have my table start at negative 10. So let's go into our table setup. All right, I'm going to make my table start negative 10, and I'll let my table change by ones. It's going to be rare that we'll ever change that. Okay, and now I want to try to find nice values. Nice values. So go ahead and go into your table. Hit second graph. Now one thing that's nice is that we immediately get a nice value. So when x is negative 10, we see that y1 is equal to negative 6. But it takes a while. Look at how messy those other y values are. I don't want to plot any of those. I don't need to plot any of those. I'm going to plot very few points. In fact, 5 of them. All right. In fact, if I scroll down, right, the next one that I see that works out nicely is when x is negative 3. And when x is negative 3, I see that my y value is negative 5. Okay? So then I can scroll not too much farther. In fact, right away I see another nice one. When x is negative 2, I see that y is negative 4. When x is negative 1, I have a bunch of them really close together that are nice. I get y equals negative 3. And now I'm going to have to work for a while to get that last one. So I'm going to scroll down a little ways. Notice all those messy y values. It'll take me a little bit, but eventually we'll get there. Ah, there's one. Okay. So, when x is 6, y is negative 2. All right, so let's graph that. We've got negative 10, negative 6, 1, 2, 3, 4, 5, 6, all the way at the limit of our graph paper. Negative 3, 1, 2, 3, 4, 5. Negative 2, 1, 2, 3, 4. Negative 1, 1, 2, 3. And 6, 1, 2, 3, 4, 5, 6, negative 2. And now we have that graph. I actually think it's a little bit better than my first one. Don't forget to put those arrows, right? That cubed root extends in both directions. So, voila. Now, part C says, describe how the graph you drew in exercise 4 was shifted to produce this graph. How was the graph? Describe how was the graph you drew in exercise number 4 shifted to produce this graph. I don't think that's grammatically correct. We'll go back and change that. But it's kind of hard because we don't have the graph sitting there. So what I'm going to do is I'm just going to have one pop right up. All right, there it is. A much better graph than the one that I drew, but there it is. Now look what happened. And actually, let's just track this one point, right? That point and that point are basically the same. And what were the coordinates of that point? There's my negative 2, comma, negative 4, right? So that means I actually took this graph and I shifted it 2 to the left and I shifted it 1, 2, 3, 4 down, right? And that's the same shifting I keep seeing, right? It got shifted left 2 and down 4. So my shifting patterns continue to hold, right? Adding 2 to the x variable shifted the entire graph left 2 units, and then subtracting 4 shifted it down 4. All right, so that's it, okay? That may be the last time we see shifting. All right, we've seen the shifting of a lot of different functions, and it seems to work the same every single time. Okay, so pause the video now. I'm going to clear this out, and then we're going to finish up this lesson. All right, let's do it. Okay, so this was probably your first exposure ever to cubed roots, unless again you had a teacher maybe in middle school who had like enriched square root work with looking at cubed roots and higher level roots. In Algebra 2, you'll see them a lot more. The fundamental idea is the same as square roots, with a huge difference being that you can find cube roots of negative numbers, whereas you can't find square roots of negative numbers. We also saw that the shifting patterns continue to hold regardless of the function type. All right. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.